Mr. Abbott here, and time for a brief discussion of the retrograde motion activity. Sorry it got clipped off at the top and the bottom. If you could put the lab number for 2018-2019, it's going to be number 16, and make sure to include your number up here to make it easier for us to organize. So I'm just going to jump right into the activity. When you look at this, the first thing that you have to do is to construct the two models on the back, illustrating the retrograde motion of both Mars and Jupiter. So I'm going to give you this model. You're going to need a ruler. Okay, I would suggest you use pencil, and then also a highlighter at the end would make it easier to visualize the apparent path of the planet. So on the bottom, you'll see there is a heliocentric model. That's actually what's happening. It's giving you the real motion. You've got Earth and Mars are orbiting around the sun. When we look up at Mars in the sky, we see Mars. It looks like a star, but unlike the fixed stars that you see in the background up at the top, planets appear to wander. The word planet means wanderer. So we're trying to get a perspective of where an observer on Earth would see Mars. First step is to take a ruler and lightly draw a line up into the background stars. So an observer on Earth looks up and sees Mars as a red star because light from the sun reflects back to us on Earth. Now, the declination angle indicates how high in the sky we're seeing it. So in month 1, we're seeing Mars at a declination of 17. So I find 17 here. I'm going to put a little circle because the lab says plot it as a circle. I'm also going to add the number. It doesn't tell you to do that, but it makes it much easier to keep track of. Now, in 1 month, Earth orbits faster. It travels a longer distance. Mars, which is farther away, is moving counterclockwise like the Earth is, but it moves a slower distance at a lower velocity. So by month 2, an observer on Earth is going to look up and will now see Mars along a different line. The other stars do not appear to move, but Mars has gone from position 1. Our declination is 16.5, so now Mars drops down to position 2. So I'm going to draw an arrow, and you'll see that Mars appears to be moving westward. Now, by month 3, both Earth and Mars are moving, but Earth is catching up to Mars. It's moving at a higher velocity. By month 3, our declination is 16, and by month 3, Mars will appear to move here. So I plot it, I number it, I connect it with an arrow. Month 4 appears like this is where we're going to start to get the retrograde motion. In month 4, you'll see that our declination is 15.5, so Mars appears to drop down to here. So the planet begins to appear to move eastward. Month 5, we look up and we see Mars. Mars is completely shifted. It appears to be moving in the opposite direction. So by month 5, I'm going to plot Mars as a circle over here. I'm going to label it 5. And you see now, instead of moving eastward, it appears to move westward. That apparent backwards motion is definitely was referred to as retrograde motion. It's going to make it a little easier if I turn my paper a little bit. 6 to 6, we look up and see Mars. It appears like a star. It's a planet. It's a wandering star. Now my declination is 16.5. So by month 6, it appears to move here. I'm connecting it and drawing it. Okay, it's still moving in the opposite direction. Now in month 7, I've got a declination angle of 18. So on that line, okay, I'm going to write that 7. Now it appears to begin to shift back to its normal direction. Month 8, Earth is at 8, Mars is at 8, so we see it along that line. So for month 8, the declination is 18. Make sure I get the right line. So the declination is 18. I'm going to label that month 8. It appears to be going this way. And finally, for our last month, month 9, I'm starting at Earth. I'm looking up and seeing Mars. The declination for month 9 is at plus 19. So when I connect that path, it appears to look like that. So to make it more obvious, I'm going to take the highlighter. You're going from 1 to 2 to 3 to 4. It was slowly drifting westward. The retrograde is where it appears to move backwards. It appears to be moving eastward, but now it's going to shift and appear to move westward again. So you'll see that if a inner planet moves past an outer planet, the outer planet appears to shift backwards. That's the retrograde motion. Now, you're going to have to do the same thing for the map of the back, which is the retrograde of Jupiter. Honestly, I've already plotted that out, and if you look at this one, okay, that's about what your model should look like. Okay, you see the same pattern, that it turns backwards, and then it seems to resume its normal eastward motion. So let's look at the questions you're supposed to do. These are not the answers to the questions, but will lead you to some of the questions. Make sure you read the passage. But for 5, up at the top, I would say highlight the line after you've drawn the line. Another indication down here, it makes it so much easier if you put the numbers on each position as you are plotting it. Now, question 1 says, which direction do the planets move around the sun? Honestly, when we look at this, the terms that I'm looking for, it's either going to be moving clockwise or counterclockwise. Please look at the 2 diagrams and determine the motion and write the appropriate answer. For number 2, it's asking you for a clear, concise definition. I've posted another video that I have a link on Google Classroom for, which is a model. Make sure you watch that video as well. But please use the following words in your explanation. Use the word apparent, use the word backward, and use the word from Earth. All right, now the next one is asking you what would happen if you were on Jupiter. Okay, which planets would exhibit retrograde motion? We saw retrograde motion of Mars and Jupiter because we were moving at a higher velocity. We caught up to and moved past it. So for this one, you should know that planets with a slower orbital velocity would show retrograde motion from Jupiter. So please list the planets that are slower than Jupiter in their orbit. The final question is asking you for a relationship. Okay, which planets would exhibit, yeah, I'm not getting the thing. Here we go. I got to slide that up more. Sorry about that. For number 4, what relationship do you get? Please phrase your answer like this. As planetary distance increases, the orbital speed, which is the rate of motion, will blank. Okay. It's going to increase, it's going to decrease, it's going to remain the same. You should know that. This is a blank relationship. Okay. It's one of those relationships that we should know. Now, this is a quick 5-point activity, but I hope this video helped you to have success with it. Good luck.